Hello and welcome to part 4 of my SPSS walkthroughs, which will be the first half of the hypothesis tests that are available to us to do some basic inferential testing, particularly to find out whether or not our null hypotheses are likely to be accurate or not. Okay, so we're going to be focusing on the tests that are done to determine relationships between variables, specifically chi-square for non-parametric data, which we're mostly using for nominal by nominal level data, or nominal by any other level of measurement. Next, we're going to be doing Spearman's rho, which is for ordinal level data. And then last, we're going to do Pearson's R, which is for interval and ratio level, or scalar data, as SPSS likes to call it. The next video will focus on group testing, or rather group hypothesis testing. So we're going to look at independent and dependent samples t-tests, as well as a one-way analysis of variance and factorial analysis of variance to do a two-way, three-way, four-way, etc. ANOVA. Okay, so let's go ahead and get started with the chi-square test. So with chi-square, you're going to be doing the analysis primarily for nominal level data. You can do it for ordinal, you can do it for interval ratio as well. It's particularly good for non-parametric data. It's particularly good if you don't have a very, very large sample size. Things like that is where the chi-square test really begins to shine. So what I want to go ahead and do is, let's go ahead and make some comparisons and see what kinds of inferences we can draw for nominal level data. So we're going to use variable 37 type rel, which is religious culture, which is broken into looks like 9 different categories. We've got Roman Catholic, Protestant, Orthodox, Jewish, Muslim, Hindu, Eastern, other, and 9 is the system missing value. And we're going to see if the type of religious culture that exists in a country is in any way affected by the region of the world that the country is in. And our categories there are Sub-Saharan Africa, South Asia, East Asia, Southeast Asia, the Pacific Islands and Oceania, Middle East and North Africa, Latin America, the Caribbean and non-Iberic America, Eastern Europe, and there's a separate category for industrialized. I have no idea what that stands for, but we'll go with it, all right? So in order to run a chi-square test, we're going to go to Analyze Descriptive Statistics, Crosstabs. Now, you can also do this a different way by going under Non-Parametric Tests, Legacy Dialogues, and selecting chi-square there as well. So there's actually 2 ways that you can get essentially the same data to pop up. I figure doing the crosstabs one is good because it allows you to see what the data that the analysis is based on actually looks like, because it's going to put all the data into a nice matrix for you, so you can kind of go in and see, if there's if the country happens to be Roman Catholic, how many instances of the countries, or rather the different regions of the world, are Roman Catholic, for example. You'll see when I do that. Okay, so Analyze Descriptive Statistics, Crosstabs. I'm going to go ahead and click that button. In all honesty, it doesn't matter as far as the test is concerned, whether the data goes in the columns or the rows. However, for the sake of standardization, it is more common to put the independent variable in the column section and the dependent variable in the rows. Again, it's not going to change your p-value if you swap it up or anything like that. But as far as what the expectations perhaps of a publication might be, or a university, they generally want you to put the independent in the columns and the dependent in the rows. So our dependent variable here is the type of religion, and we're examining that based on the region of the world that the particular variable that the particular country is. Sorry. Now, you may have remembered that I suggested that you don't listen to the measure that many of the variables are put into in SPSS because they're usually wrong. Well, in this particular instance, type of religion is definitely not ordinal, and the region of the world is definitely not scalar. So, they're both nominal level data. I could go in and change that in the database, but, I'm just going to leave it in there because it doesn't really make much of a difference. Okay? So now that we've moved our variables over into the row and the column, we're going to click on the statistics button here, and it'll bring up crosstab statistics. So just because we're going to be coming back to this time and time again with the other hypothesis tests as well as the correlation tests, and for some of the effect size tests, we might as well kind of walk through the most commonly used ones that I'm going to be showing. But there's a lot of options here for you to potentially to look at. Okay, so chi-square and correlations at the top. That's going to be the most important. We're going to click off on chi-square for this one since we're doing a chi-square. But if we're going to be doing the Pearson's R and the Spearman's Rho tests, we're going to want to check off correlations there. For correlation strength, we have all these different options here. Contingency coefficient. Find Kramer's V for nominal level data is one of the more important ones that I'm going to be showing in a subsequent video. Lambda is a good effect size, proportional reduction in error test that I'll get into in the future as well. There's also the uncertainty coefficient. For ordinal level data, we're going to in particular be interested in Kendall's tau B and C. We do have gamma. Gamma doesn't like tied pairs though, so ignore that. Just we're mostly going to be focusing on Kendall's tau B and C in the future. We have eta for nominal by interval data. Eta squared is a fantastic proportional reduction in error effect size test as well. I've never actually used Kappa, RISC, or McNamara, or Cochrane, and Mantel-Haensel statistics. But those are other things that, perhaps you're going to take some advanced statistics classes, or maybe in getting your PhD, you're going to be interested in doing some of these types of tests. I'll leave it to that. In this particular set of lessons, and this particular set of walkthrough videos, we're going to be focusing on chi-square, correlations, phi and Kramer's V, and then Kendall's tau B and C primarily. And then I might show eta if I remember to do so in the future. Okay? But for right now, we've got chi-square checked off. Let's hit continue, and then we'll hit OK. And then, bam, we've got our case processing summary, which gives us our valid number of cases and what percentage of the whole that represents. Our missing cases, apparently 2 countries did not respond to this. And then the total, which is 114 countries represented, which would be 100%. Okay? So now, like I said, we have this crosstab where we take each of the different categories for the regions and we line them up with each of the categories for the religious categories. So in sub-Saharan Africa, for example, there are 8 Roman Catholic countries, 4 Protestant, 13 Muslim, and 1 Hindu country, and 8 other, for a grand total of 34 different countries. And you can go to any of these different sections here and get the general breakdown of what those countries are like. Okay? So that's all well and good and interesting to look at to see where your data is coming from. Of course, if you have interval and ratio level data, it's a very, very large matrix indeed. And for most instances, you might find that there's only one individual value that corresponds to another individual value from the other variables. So it's not as interesting when we go beyond nominal and ordinal level data, but nevertheless, you know, it does show a lot of interesting information here. Okay, but what we're most interested in here is the chi-squared tests window here. So in particular, we're interested in the row that says Pearson's chi-square or Pearson chi-square. It gives you your value here and your degrees of freedom. So if you want to go and do the old school way of checking to see if your observed value is more extreme than the critical value on a chi-square table, you know, if you go ahead and just quickly open up a search window and look at chi-square, we've got, we can look at a chi-square table under images here, and based on our confidence level and our degrees of freedom, we're able to see what the critical value is here. This is not the best chi-square table because it only ends at 14, but you can go ahead and get a bigger one. Here's one for 30. Probably one for a good 60 to 100 values as well would be what you're looking for in this particular instance. But you'd be able to look up the critical value and compare it to the value that you found. Fortunately for us, SPSS is going to take all that headache away. You don't have to look for any of these tables. You don't have to, put in any more effort than you have to. You just need to look at this last column here, the asymptotic significance two-sided. And that's your p-value right there. So here it says 0.000, which means that there's less than a 1 in 1,000 chance, basically, that your null hypothesis would be an accurate representation of the data. So what you can actually do is go ahead and double click on this, and it will tell you the exact value that that number represents. Remember, this 0.00, it's asymptotic. There's no such thing as a 0% chance of pretty much anything in statistical analysis. So here we have 6.116 times basically 10 to the negative 21st. So if we moved our decimal place over 21 spaces to the left, so 0.020s, oh wait, I said that wrong, 20 zeros, 61116 is the exact p-value that you have. So you're very confident in this case to reject your null hypothesis and assert that indeed there's probably a statistically significant relationship between the region of the world that a country is in and what their religious culture is likely to be. Okay? So that's how you run a chi-square. Now let's go ahead and do a Spearman's rank correlation coefficient or row test, which is primarily good for ordinal level data. So let's go ahead and use a type of secular or religious society because you have most secular, moderate, and most religious. So there is an order to it. So that's going to be a RelCat. And let's find, how about least demographic to most demographic on a scale of 1 to 7. So you can have 2, 3, 4, 5, and 6 in there in between, which somewhere lies between those most and least democratic values. Okay, so let's see if religious category affects how democratic a country is. Okay, so let's say you have a theory that, religion might have some sort of an effect on whether a country tends to be democratic versus authoritarian. And what you can do is put relcat as your independent variable that's going to be affecting, what was the variable? It's the Freedom House Democratic Rating, so that's FH03Rev. Very good. We're going to click on this again. We can do a chi-square test. It's perfectly, valid to do a chi-square test. There's nothing that says you can't. But I'm also going to check off the correlations because we are indeed interested in Spearman's rho instead of chi-square for this particular one. So I'm actually going to check off of that. We're going to go ahead and hit continue, and then OK. And we have a new set of data. Again, same general idea for the case processing and the little matrix of different values comparing the independent to the dependent variable. But then down here, we look at symmetric measures. Okay, so if you'll notice, we do have interval by interval, which says Pearson's R. Hint, hint, wink, wink. When we do interval and ratio level data to do a Pearson's R test, we're going to be doing it exactly the same way. We're going to be clicking the same box. It's going to give us both the Pearson's R and the Spearman correlation values. Okay, so the value here is what is important for your correlation itself, to find out correlation strength rather. But for the current purposes of doing statistical significance, determining whether or not your null hypothesis is true or not, we're going to do it based on this approximate significance value. Okay, so it's 0.000 again. So let's double click that and see exactly what that number represents. So 0.000347. Again, that's less than 3 in 10,000 roughly chance of the null hypothesis essentially being an accurate reflection of the distribution. So we're going to once again reject the null hypothesis and assert that there is a statistically significant relationship between the type of secular or religious society that a country is and what their Freedom House Democratic Rating is. Okay? So that's Spearman's, and you kind of know what's going to be happening now for this interval and ratio level data analysis, which is for, of course, Pearson's product moment correlation coefficient, or R. Let's go ahead and see if total population, which is POP 2002, in any way influences how about the urban population? I mean, it kind of makes sense that, urban centers tend to be places where there's a higher concentration of people. So maybe the higher the population of a country, the more higher the percentage rather of the population being in an urban area is. Okay, so let's go ahead and try that. So we're going to do, again, analyze descriptive statistics crosstabs. And again, you could do this by doing correlate bivariate. I didn't mention this for ordinal level data. You can do it for that, and it should also spit back your Spearman's rho values. But we're gonna stick to crosstabs here just because no good reason really, just because that's the way I feel like teaching this right now. Okay, so we're going to look at urban. Urban's going to be our dependent variable, and then population 2002. So we're asserting that population's affecting the percentage of the population that lives in an urban area, not vice versa in this particular case. Again, we're going to hit statistics, correlations here. We're going to hit OK. And again, case processing summary. Like I said, when you have interval and ratio level data, you're going to have a whole heck of a lot of different values in this matrix. So it might get a little bit too large to handle. But again, symmetric measures, that's what we're most interested in. So this is our actual Pearson's R value for when we do correlation testing. Again, I'm getting ahead of myself. We've got standard error and our approximate t-value, but we're Most interested here in the approximate significance. In this case, it's 0.214. Okay, so that basically means that the probability that random forces could have led to this distribution, or that the null hypothesis is true, is about 21.4%. Right? So if we move the decimal place over 2 spaces and stick a percentage sign, 21.4% chance that the null hypothesis is true. And generally speaking, in the social sciences, our cutoff is going to be at p being less than 0.05. So here, p is significantly greater than 0.05. So in this case, we're not going to be rejecting our null hypothesis. Instead, we're going to be asserting that there's too much of a risk that the null hypothesis is true. There's too much of a risk that we'd be making some sort of an error in our prediction. So instead, we're going to say that there is no statistically significant relationship between population size and the percentage of the population in urban areas. And really, if you really sit down and think about that, it kind of makes sense. There are small countries, there are big countries, small countries with a big urban population, large countries with smaller urban populations and larger urban populations. So yeah, it makes sense that it's kind of randomly distributed in that sense. Okay, so yeah, in each of these instances, we're looking at the right, and usually the top right, if not the second from the top, to make our determination of what our p-value ultimately is, and how we come to a conclusion about whether there's a statistically significant relationship between the variables that we're examining. So again, if this value is less than 0.05, then you reject the null hypothesis and you assert that there is a statistically significant relationship. If it's larger than 0.05, as it is in this case, we fail to reject that null hypothesis. We assert that there is no statistically significant relationship. Okay? So with that, that's hypothesis relationship testing in a nutshell. Next, we're going to be doing group hypothesis tests, which are the t-tests and the ANOVAs.